Welcome to all of you. After completion of electromagnetic induction as well as alternating current, now we will discuss about the new unit which is known as the electromagnetic wave, and it is totally based upon the electrostatics as well as the magnetism. And all the previous part, main part of that particular units was used here. First of all, I want to introduce you what particular topic we will discuss here. First one, we will discuss here electromagnetic wave. What is the EM wave? We will discuss, and after then we will discuss properties of the electromagnetic waves, as well as third and last point is here electromagnetic spectrum. And it is very important, it is learning part of that particular unit, in which we will discuss about the wavelength and the frequency range of each and every type of the electromagnetic wave. There are 7 type of the electromagnetic waves. 7 electromagnetic waves will have different wavelengths as well as different frequencies, and what are their sources by which they was to be produced, as well as where we will use them, is also a study part of your this one unit. And whole of the unit is totally theoretical, and you must be learn all these things, so that approx 3 to 5 mark question will ask in board exam. Now we will discuss what is the electromagnetic wave, and before just going forward in that particular topic, I want to introduce you what is the conduction current and what is the displacement current. Conduction current and displacement current. Conduction current is I, simply I, you know very well, and displacement current is representing by the ID. Conduction current is known as the rate of flow of charge, you know very well. It can be written as the dq over dt. As DC, direct current, you have studied at the current electricity chapter, but displacement current is the current which is given as the epsilon naught, and it will be cyclic integration of the d phi e over dt. Mean to say, if electric flux will change rapidly, then that particular displacement current will produce. Practically, it is observed that conduction current and displacement current are similar, they are equal to each other. And how it will produce, I will want to give a general idea to you, so that you can understand it in your mind. Suppose it is a parallel plate capacitor and it is connected here with a battery or cell, followed by a rheostat, so that you can change the variation of the current here. A key is also connected, and that particular capacitor is connected like that. Potential applied here, you know, when we will close the key and current will flow in that particular circuit. Gradually charge will store in the plate, as well as charge will increase. Electric field between the plates must to be set up, and it will also increases its strength, because you know very well electric field intensity is equals to the sigma upon epsilon naught for a particular sheet or plate. For sheet it is sigma upon 2 epsilon naught, and for plate it is sigma upon epsilon naught. So here you want to write, that is the rate of change of electric flux. Electric flux means total number of electric field lines passing through a given area. Rate of change of electric flux is just responsible to production of the displacement current. So what is the relation? Conduction current and displacement current together have the property of the continuity. Conduction current and displacement current are precisely the same. Conduction current arises due to the flow of electron in the conductor, and displacement current arises due to the electric flux changing with time, as discussed here. Before going forward, I want to write again what is the value of the displacement current. Again I will write here, it is epsilon naught times of the rate of change of electric flux. Okay, it is given condition, and you must be learn that formula, so that you can use it easily in the further study. And now I want to discuss what is the Maxwell equation. What is the Maxwell's equations? Maxwell equations. There are 4 equations of the Maxwell's. First equation, what is the first equation? It is Gauss law in electrostatic. Tells to you cyclic integration of the E dot ds or dA is equals to the q upon epsilon naught times. Okay. Number 2, second, cyclic integration of the magnetic flux B dot ds over dA. You can write ds or dA here, will always be equals to the 0 is the second Maxwell equation, and third Maxwell equation is just Faraday's Lenz law. It is Faraday's Lenz's law in electromagnetic induction, and according to that particular condition, E dot dl, I am writing here, cyclic integration of the E dot dl is written as d over dt of cyclic integration of the B dot ds. Mean to say, it is third equation just informed to you, that is rate of change of that particular magnetic flux is responsible to creating the electric field is the third Maxwell's equation, and fourth equation is the Ampere's Maxwell law. According to the Ampere's law, if you want to write, you can write easily, cyclic integration of the B dot dl is given as the mu naught times of the I net, and I net will be sum of displacement current and conduction current for a given circuit, because in that particular figure where a particular plate was given, parallel capacitor plate was given, it was connected with a cell or battery. You know, here conduction current will take place, and between the plate the change in the electric flux is known as the displacement current. So ID was given as epsilon naught times of the d phi E over dt. So therefore we can easily write that particular equation here. Finally it becomes B dot dl equals to mu naught times of the I plus mu naught epsilon naught times of the d phi E over dt, and all these equations are known as Maxwell's equations. There are 4 equations it can ask in a exam for 1 marks. So now we will discuss what is the electromagnetic wave. Electromagnetic wave is the variation of the electric and the magnetic fields perpendicular to each other and producing electromagnetic disturbance in the space at right angle to each other, which have properties of the wave and propagate through free space without any material medium, is known as electromagnetic wave. Electric field vectors is given along to the y-axis and magnetic field vector is given along to the x-axis. Then what will happen? Electric field vector must to be oscillate along to the y-axis, and all the electric field vector is oscillating upward as well as the in downward direction, and you can easily draw the value of the magnetic field. Propagation of the magnetic field vectors is given like that, and they must to be oscillate along to the z axis, and with the oscillation of the electric field vector as well as the magnetic field vector, electromagnetic wave will propagate along to the x axis, and it is known as the electromagnetic wave. EM wave will propagate along to the x axis, it is conditioned. So what is the electromagnetic wave? For a region where there are no charges and the conduction current, then according to Faraday's and Ampere's law takes the symmetrical form, we can write here cyclic integration of the E dot dl equals to d phi over dt, and cyclic integration of the B dot dl equals to minus mu naught epsilon naught d phi over dt. We are just assuming here there is no conduction current and there is no charge, then we will have that particular formula. How it will obtain here? You know, here it can be written as the Faraday's law just informed to you, E equals to minus d phi b over dt. Okay, it is a condition, that is induced EMF equals to rate of change of magnetic flux is the Faraday's law, and you know here that particular induced EMF can also be written as the potential, and at the earlier chapter you know very well what is the potential gradient. Electric field intensity is written as the dV over dr as a potential gradient, and suppose r is treating as a here L is the length or distance, therefore dV can be written as E into dl or not. Okay, and therefore we can write here V equals to integration of the E into dl. So what is the condition? You can easily understand, and just putting the value of V here, you will get the result. Cyclic integration of the, for the complete cycle, it is E dot dl is given as the minus d phi b over dt, and it is known as Maxwell's third equation, as well as here it is written as the total potential provided by the particular electric field vector is always rate of change of the magnetic flux. If magnetic flux is rapidly changes, then electric field will produce, and with the help of that particular formula which is known as the conduction current, you know very well, in that particular situation electric flux is rapidly changed, then it will produce the magnetic field. Mean to say, electric field propagation as well as the magnetic field propagation, like here as well as here, electric and magnetic field vectors are rapidly changed to each other, and they will propagate the electromagnetic wave which must to be travel 3 into 10 power 8 meter per second without any material medium in space. It can also be shown that time varying electric field produces the space varying magnetic field, and time varying magnetic field produces space varying electric field with the equation. And here it is given like ratio of them, and magnetic field is represented by these two formulas, and all the formulas are simple and must to be learned by you so that you can write in the exam. Electric and magnetic field are source to each other, and here electromagnetic wave is a wave in which electric and the magnetic fields are perpendicular to each other and also perpendicular to the direction of the propagation of the wave. Now we will discuss about the properties of the electromagnetic wave, in which suppose x axis is given here, it is a y axis and it is a z axis. Along to the x axis electromagnetic wave is propagating, where blue is just representing the electric field vectors propagating along to the y axis, as well as the magnetic field vector is propagating along to the z axis. Is it clear? And in that particular situation, you know very well, if that particular position is representing the electric field maximum oscillating vector, that is displacement you can say, and here magnetic field displacement. Then due to the electric field propagation and magnetic field propagation, both the vectors will propagate in such a manner so that electric field will propagate along to the x axis like that. And what is the property? First property is here, the variation in both electric and the magnetic field occurs simultaneously, therefore they attain their maxima and minima at the same place at the same time. It is the first property. And second property is here, the direction of the electric and magnetic fields are mutually perpendicular to each other, and as well as to the direction of propagation of the wave. And third property is here, the electric field vector E and magnetic field vector B are related by a particular formula, C equals to E naught by B naught, where E naught and B naught are the amplitudes of the respective fields and C is the speed of the light. And that particular concept can also be understood with the help of velocity selector. You know very well, velocity selector was given as the E by B. If a charged particle was just moving in a particular electric field as well as the magnetic field at the last chapter, then a particular force, magnetic field force, was directed here. If a velocity of the charged particle was given and moving at angle theta. Suppose here a particular electric field is also applied along to the minus y axis, then a particular magnetic force is also acted on the positive charged particle along to that particular direction, and that particular force is known as electrostatic force. At equilibrium condition, if Fm equals to Fa, both the forces are equal and just opposite, then it must be given as the QVB, and you know it must be given as the Q into E. Charges will cancel out, therefore velocity can be written as the electric field and magnetic field in a ratio E by B. Okay. So now I want to tell you, in that particular condition, velocity selector is here, and suppose it is propagation of the electromagnetic wave, its speed or velocity is the c, and its maximum amplitude for the electric vector is here and maximum amplitude for the magnetic vector is here. Then you know very well, you will put here E naught by B naught will give the relation for that particular third property of electromagnetic wave. And next we will discuss fourth property is here. In that particular situation, fourth property, the velocity of the electromagnetic wave in free space is this one be c equals to 1 upon under root mu naught and epsilon naught. It was also proved in a Biot-Savart's law at the starting of the magnetic field. Next, fifth part is here, the velocity of the electromagnetic wave in a material medium is given as 1 upon mu into epsilon. You know very well, mu is the permeability of the medium and epsilon is the permittivity of the medium. So, if it is given as a medium, then it must be given for a particular medium. If it is given as a vacuum, then it must be given for a particular vacuum. So, therefore, velocity is in a medium and velocity in space will be c, that is the speed of the light. And next sixth part is here, electromagnetic waves obey the principle of the superposition, mean to say net displacement will be the vector sum of the displacement produced by each and every wave. If number of the waves are accumulated at the same point, then they must be following the principle of superposition. And electromagnetic wave carry energy as they propagate through the space. This energy is divided equally between the electric and the magnetic fields. It is 50-50% divided for both. And next, electromagnetic wave can transfer energy as well as the momentum to the object placed on their path. It is very important to ask in a board exam. And next, ninth part is here, for discussion of the optical effect of the EM wave, more significance is given to the electric field E. Therefore, the electric field is called the light vector. And next one part, 10th is here, electromagnetic waves do not require any material medium for their propagation. They can travel without any medium. And oscillating charge which has non-zero acceleration can produce electromagnetic wave. And that portion is also removed from your syllabus. It is proved with the help of Hertz law. It is not in your syllabus. Okay. At the last of the study of that particular unit as well as chapter electromagnetic wave, now we will discuss about the electromagnetic spectrum. There are 7 types of the electromagnetic waves. I will discuss what is the name of the waves as well as their ranges, wavelength as well as frequency, what is the source and use of them. So here, that is the first electromagnetic wave is treating as a radio wave, and it is from a few kilometer to 0.3 meter is the wavelength of radio wave. Radio wave frequency is from few hertz to the 10 to power 9 hertz, and it is a source by which it can produce is oscillating electric circuit, and uses radio and TV broadcasting in which they will use. Number 2, microwave. It is used in a microwave oven as well as radar. You know, microwave, its range that is wavelength is 0.3 meter to 10 to the power minus 3 meter. Frequency is 10 power 9 hertz to 3 into 10 power 11 hertz, and source is also oscillating electronic circuit is the source by which it can produce. What are the uses? Radar, analysis of the fine details of the atomic and the molecular structure, and microwave oven. And third, infrared waves, 10 power minus 3 meter to 7.8 into 10 power minus 7 meter, and frequency range is 3 into 10 power 11 hertz to 4 into 10 power 14 hertz. It is just produced with the help of the molecules and the hot bodies, and it can be used in industries, medicine, astronomy, night vision devices, greenhouse, reference screen writing on the ancient walls, and the etc. These are the uses. Light or visible spectrum. Light or visible spectrum is wavelength is given 7.8 into the power minus 7 meter to the 3.8 into the power minus 7 meter, and its frequency is 4 into 10 power 14 hertz to 8 into 10 to the power 14 hertz. And how it will produce? Atoms and the molecules when electrons are excited and just jump from higher to lower or lower to higher orbit, and they can use in optics as well as the optical instruments, vision as well as the photography. You can see each and everywhere. That is the visible light. Next, we will discuss fifth number, ultraviolet rays. Ultraviolet rays are having the range 3.8 into 10 power minus 7 meter to 6 into 10 power minus 10 meter. And what is the range of the frequency here? That is 8 into 10 power 14 hertz to 3 into 10 power 17 hertz. Source, atoms and the molecules in electrical discharge, and the sun is also source of ultraviolet rays radiation. And what is the use? Medical applications, sterilization, killing bacteria and germs in food stuff, and detection of the invisible writing and forged documents, fingerprints, etc. We will use the ultraviolet rays. And next and second last part is the X-ray, 10 power minus 9 meter to 6 into 10 power minus 12 meter, and range is given here 3 into 10 power 17 hertz to 5 into 10 power 19 hertz. And how it will produce? Inner or more tightly bound electrons in the atom are producing the X-rays. And you know, X-ray is a very common name. You can use it. X-ray photography, treatment of the cancer, skin disease and tumor, locating the cracks and the flaws in the finished metallic objects, reduction of the smugglers goods in bags of the person, and study of the crystal structure, etc. we will use it. And next and last point is here, that is the gamma rays. They overlap the upper limit of the X-ray, that is 10 power minus 10 meter to 10 power minus 14 meter is the wavelength of this type of the waves, and here it is frequency range 3 into 10 power 18 hertz to 3 into 10 power 22 hertz. Radioactive substances are responsible for their production, and where we will use information about the structure of the nucleus and astronomical research, we will use all of them. So that is the part of the electromagnetic wave here, and it is very easy to learn, and you must learn all these ranges because it will ask 2 marks for the 2 marks in board exam. Okay, it is the last part of your study, and it is the last of the end of the EM wave.